Hello guys, so in this video I will discuss more about thermodynamics. In the previous videos I have discussed about this equation delta Q is equal to delta U plus delta W, and basically the pressure, volume and temperature is given by this equation, where we have, say, this piston, we have this gas and we have piston. Say there is certain pressure P, and say there is some movement dx, and say the area of this is A. So basically if we want to calculate the force, it will be given by P times A. This is force, and say it moves by dx, so work done will be F dx, which will be P A dx. This is how you can calculate the work done. So if, say, we have a constant pressure, so in constant pressure case what will happen is the total work done will be given by integration of dW, that is P is constant, A is constant, so only thing will be this. So this is A times, say, from x1 till x2, so this is x2 minus x1, and this will be delta V. So this is basically the change in the volume of the gas. Now if we use this equation, PV is equal to nRT. So P is constant if we take the derivative of this, so delta V, N is constant, number of moles is constant, this is constant, and then delta T. So change in volume is directly proportional to change in temperature. So we can basically calculate this value nR delta T by delta V. We put this value here, the work becomes nR delta T by delta V, change times delta V, so this becomes nR delta T. So this is the change in temperature of the gas. So if the change happens from T1 to T2 in the constant pressure case, the work done you can calculate. And say, so this is constant pressure case. Now let's discuss about constant temperature. What is work done? So PV is equal to nRT again, and work done is given by dW, so we can say P dV, change in the volume, small volume. So if we take the differentiation of this equation, this becomes P dV plus V dP is equal to nR dt. But since it is a constant temperature case, so this becomes 0, so P dV becomes minus V dP. Now we have this equation, right? So what we want to do is so here what we do is W is equal to, we put the value of P from here, this becomes nRT by V dV. T is constant, this becomes out, and this becomes like this, V1 to V2, this becomes nRT ln V, V1 to V2, nRT ln V2 by V1. So this is the work done, total work done in the case of constant temperature. And if you want to calculate this in the form of uh, say P, then what we do is since PV is equal to nRT and this is constant, so we can write P1 V1 is equal to nRT, P2 V2 is equal to nRT. So P1 V1 becomes P2 V2. So if we calculate V2 by V1, then it becomes P1 by P2. So we can write nRT ln P1 by P2. So these are same thing. Either you can calculate from here or here. So this is the basically work done in the case of constant temperature. So we have a constant temperature, we have constant pressure. Now we talk of constant volume, and this is very easy case. Constant volume. So PV is equal to nRT again. We have W is equal to integration of P dV. Since change in volume is 0, so this becomes 0. So work done in the case of constant volume is 0. Now we have thermodynamics equation delta U plus delta W. Since this becomes 0, so any heat which is supplied to the system will be stored in the internal energy of the gas, or either if there is a drop in the internal energy of the gas, then there will be heat escaping out of the system. So this is all about in this video. I will talk more about in the next videos. So thanks for watching this video. If you have any questions, you can put below and I will try to solve those problems for you. You can just put the number of problem number, or if you want to solve get it solved, or you want to understand any concept in physics, you can basically just comment it down, and you can like, share and subscribe. Thank you.